All right, so now where are we going to go from here? This is going to be a very kind of packed video compared to the first one. So what this video will allow you to do is script a button object that you like a physical button shaped thing that you can walk up to in the world and press the E key on the keyboard to like the action button and trigger something to happen. In this case, I think I have an idea of what I want to trigger happen because it's easy enough to do and it highlights how to use the physics engine too, which is kind of cool. So the event that we're going to trigger with this button press is a boulder is going to fall down a ramp, and it's going to be like a trap, like an Indiana Jones kind of trap. So first I just want to highlight how easy it is to block out basic shapes and scenes with your prototyping. You don't really need to know a complicated 3D modeling software package to be able to do prototyping stuff. So I'm going to show you that first. So let's create this ramp. So if we go to game object up here, we do 3D object and cube. You see create this cube here, but it's below the plane, so I'm going to drag this little handle and get it above ground. Now, one thing that's nice is with these primitive objects, the cubes, the spheres, whatever, you can scale them non-uniformly. So if you select the scale tool and you select only one of the colored handles, you will only scale in that axis, which is kind of what I want for this purpose. So I'm going to scale this cube and squash it so it's kind of like a flat plank. And then I'm going to scale the Z a little bit just to make it a little bit wider, and then in the X I'm going to scale it a lot. I'm going to zoom out a bit. And if you forgot the camera controls, it's covered in the first video up around the halfway mark. So, I'm going to get it about this big, like really long, because I want this ramp just to have a boulder that goes down it. I'll widen it just a little bit. And then cool. So that's the shape of the bottom of the ramp. So I'm going to rotate this now to the angle that I want, which, this is pretty good, whatever. So I'm pretty happy with that. I'm just selecting, when you have the rotation tool selected with an object, you can just click on any of these rings to rotate in that axis. So that's simple. And yes, I want kind of like an angle, something like that. And so I'm going to get this move tool, and I'm going to drag it back to being above ground, like this. And I want to create railings for it so the boulder doesn't fall off the edges of the ramp. So I'm with this bottom of this ramp selected, I'm going to hold Control and hit D for duplicate. And now I can move this over. I'm going to scale it to be much less wide than the ramp, right? And like something like that. Then I'm going to move it over so that it connects with the thing again. And then I can scale it in this Y direction like this. You see? And I can also pull it up as well. So and here's the thing, you notice how right up here I have this local button where my mouse cursor is. You can click it and see what it does, but there's this distinction in any 3D software of global versus local coordinates. And when you have objects that are kind of nested, that distinction starts mattering, because you can have an object that's at a 0, 0, 0 local coordinates because its parent's location is matched up with where it is, but its parent might not necessarily be 0, 0, 0 in the global coordinate system. So that's one of the things that takes a long time to understand, but just being aware that there are different ways of representing coordinates that are very necessary to have those distinctions. It helps to just be aware of that. So now we got the edge, the boundary, like the right boundary of the ramp. Let's select this boundary now and hold Control, hit D, and we can move it to the other side. And all these 3D primitives already have colliders attached to them already. So these are ready to go with physics. Now I just want like a sphere. So I'm going to add a game object, 3D object, sphere. And I am going to kind of drag this over, utilize the scene camera to kind of get it to where I want it to be. I want to have this sphere kind of, this boulder, hovering kind of just above the mouth of the ramp. So yeah, maybe something like this. Also, I want to scale it a bit, make it a little bit larger so that it kind of fills in this the ramp a bit. That's perfect. Not too wide, not too small. And another thing is I'm going to rename this game object. So I got this sphere object, but I want to call it a boulder so we know what it is. Because when you're prototyping with a lot of these little primitives, you're just going to get names like cube, and then cube 1, cube 2, and so on. So to call this thing a boulder is neater. And these individual 3 parts here of the ramp, the right wall, the bottom, and then the left wall, they're also just named cube. So we can see as we select them here in the hierarchy, it's like cube 3, cube 2, cube 4. So cubes 2 through 4 are just the ramps. So what we can do, just to neaten this up, is we can grab cube 3 and 4, like shift select both of these, click and drag them over the cube 2 game object and let go. And now you'll see that cube 3 and 4 are now children of this cube 2. You got this little collapsible arrow. Now what we can do is on cube 2 we can rename it to ramp. So now it's neater, right? Because now we have this ramp and this boulder, and we know these objects by name because we've named them nicely. We know what they are based off their names and stuff. So here's the thing. This sphere that we have has the default sphere collider, but because it doesn't have something called a rigid body, the physics engine is kind of going to ignore it as far as influencing its movement via gravity and collisions, really. This thing is something our player could collide with, but we can't influence the movement of the boulder because it's not a physics object, which is actually kind of the mechanism that we're going to use on this switch. Because basically, and in real time through code, we can grab a reference to this boulder when we press the button, when we activate the button press on the switch. We can basically just add a rigid body component to this sphere, and the physics engine will take over. So that's what our actual implemented code when we press this button is going to be. So just so you know. Now, cool. So we have this set up, or at least the boulder part. Now, so we got this box here, and this box would be a good candidate to call it a button, right? I mean, we could do that. We could, maybe we can decorate it just a little bit more just to make it clear that it's a button. So, for instance, we could do, we can go to game object, 3D object, and then cylinder. Cool. So add this cylinder way out there. I'm going to grab this move tool, kind of drag it up a little bit, and just kind of bring it over. Just remember those camera controls I covered with the first video. And so this will be our button, but we want to squash a little bit first, right? And scale it a little bit. So let's scale it down in the Y so that it's more shallow of a button. And then just scale it down in general, right? And we also need to rotate it because we want it to be on the side of this box, right? So we get the rotate tool. If you want to rotate in like 15-degree increments, you can hold control. So then when you hold control and click and drag any of the rings, you'll see it will snap in those nice, I think it's 15-degree increments. So that's how much we want to rotate. Now I can grab the move tool, drag this kind of to the center of the box, is kind of how I imagine it. It's arbitrary though what this thing is going to be shaped like. The colliders and the shape of the colliders is going to matter much more. And let's color this button so that it stands out against the white. So we clearly know this is a button, right? So cool. Now this button is called cylinder because it's just a cylinder that we've modified. But let's call it button so that we know that this is a button. Alright, so now from a game object's point of view, we're set up and the rest is just scripting. We have a button with a collider on it, so we can interact with that in some meaningful way. We have the ramp with all the colliders on it, and we got the boulder. We want to make it so that when we press the button, the boulder all of a sudden falls down the ramp. And also if we're thinking in terms of game design, we can click this box, hold Control, and also select the button that it belongs to. And then with both those selected, we can kind of move it closer to the ramp. Because if this was like a game scenario, it's like this is a trap, right? So we want the player to be near the ramp when they touch the button. So we can have it off to the side here. So they'll go and touch the button and then, oh shit. So just a little funny game design consideration. Not really necessary for the tutorial, but so now we need to start scripting because we have all the game objects set up. So everything in Unity is a game object, unless you very explicitly say, no, this is just a standard C# system.object. But game objects in Unity are a custom class that Unity created to make your life as a developer of games easier. So in this hierarchy, you can think of each individual item in this hierarchy panel as being a game object. Just from existing in this hierarchy panel means it's a game object. And being a game object gives you access to things like components, like a box collider is a component, a mesh filter is a component, a mesh renderer is a component. And game objects also allow you to disable them without destroying them or like garbage collecting them from memory. And there's also a destroy method for destroying game objects, which will tell the game engine to free up the memory that this thing took up, and any scripts running on that object will also just be pulled out of memory and no longer be running. So game objects give you a lot of basic behaviors as well as specific ones that you can add on top of it. So when we script, the code that we write is most of the time going to be in the context of what it's doing to game objects, just as a kind of general guideline. So we want to create a scripts folder in our assets folder here by right-clicking and then do create folder if you don't have one already. So once you create a scripts folder, let's go inside of it, do create C# script. Now, from an object-oriented design of C# code perspective, you mentioned you have a lot of interactions that you want to be able to do with certain objects. And in terms of what happens when you have those interactions, like if you press the action button on a button, something different can happen depending on the button, like some action could occur, right? We're not concerned with what occurs right now, we're just concerned with what is the player's interaction with a button. Well, we go up to it and we press the E button. And kind of the same thing with the lever, right? So the lever is also just something that we go up to and press E. So we want to, in C#, we have a really great structure called an interface. And interfaces let us say, here's a contract that some scripts can take on, like can inherit or implement. So you implement an interface. And what that means is as soon as you declare that a class is implementing an interface, you are saying that this class will take on all the behaviors of this interface. So it doesn't make sense right now, but let's name this script iActionable object. And now we can open it in our code editor, so double click it. And here's what we're going to do. We're going to modify this code. Instead of being a class, we're going to make this a interface. And we're going to remove this colon mono behavior. And we're also going to remove these two blocks of code, the start and the void method. And what we're going to type here in this code block is just void, meaning this is a method that will return nothing. And we're going to call it do action. And yeah, open, close parenthesis, semicolon. And now we have declared an interface. This is all this is. It's just a contract that says any class that inherits from iActionableObject, let's spell it correctly, will have to implement a method called doAction, case sensitive to how you cased it in the interface, that returns void. That's all this is saying. Now let's actually write a class for a button that implements this interface. So let's minimize this code editor window. Let's right click in the scripts folder again, do create C# script. We're going to name this one button. Bang. Now let's open our button script. Now we got this public class button inherits from mono behavior. All classes in Unity by default inherit from mono behavior. It gives you access to all the custom classes and types of the Unity engine, such as game objects and stuff. So if you don't care about game objects, you're just writing some abstract code to back up the code that you write, you can remove it. But we want button to be a game object because we like all the things Unity has to offer, so we keep this inheriting from mono behavior base class. But after mono behavior, we're going to type comma and then iActionableObject, because we want to say that this button has all the nice things that Unity has to offer, and we could also call it an iActionableObject. Now let's go up to this tab that says build, click it, and do rebuild all. And you'll notice it throws its arms up and says button does not implement interface member iActionableObject.doAction. The reason why it's complaining is because that's just what an interface does, is it makes sure that your button objects will always have the ability to have a do action called on them. So it's a generic thing that's very important in this contract. So here's what I'll do. Above this void start method here, I'm going to do public. And it always has to be public when you're implementing members of an interface. That's just one of the rules of an interface. So public void do action, open close parentheses, open bracket, close bracket. Now if you click rebuild all again, as far as Unity is concerned, or C# rather, as far as the C# compiler is concerned, your button fulfilled its contract of an iActionableObject. We have a method signature for do action. However, no code occurs in it, but it still is okay. It's just not, it doesn't do anything yet. But so now that we actually have this method, we need to have a behavior, something that happens, right? So the actual thing that happens. So in the case of this button, how can we genericize that this button can have just anything happen? Let's see. So let's just make this specifically a Boulder button. I don't know how to genericize a button so that it does multiple things, but so this is specifically going to be a button that releases a boulder. So I'm going to call it Boulder Button. In a later tutorial, I might show you how to make it just a generic button and make it a button that could result in a boulder falling or a bridge falling or a door opening, stuff like that. But right now, this is specifically a Boulder button because my programming brain can't figure out how to do this yet. So basically, do action, we're going to want it to grab a reference to that boulder and add a rigid body to it. And that's all that we need to do in order to make that interaction, right? So what we're going to do is, in this do action method, we're going to declare a variable. We're going to call it boulder. This is just the name of the variable, so it's arbitrary. It can be anything, but we want it to be descriptive. So var boulder, set it equal to game object with a capital G dot find, and we're going to pass in a double quotes boulder. And this is case sensitive, so whatever you named your boulder game object in the scene, however you capitalize it, it needs to be exact. So we're doing game object dot find, and game object dot find returns a game object, right? So now boulder will contain the reference to this game object because it's going to find it in the hierarchy. That's what game object dot find does. Now we want to add a rigid body component to the boulder. So now check this out. Boulder is just a game object. So if you do boulder and then dot, the dot notation, you can see all the methods and members that belong to the game object class. So you can do a lot of things to this boulder. We want to add a component to it. Add component is a generic method, which means that we have this syntax of we need to say what kind of component we want to add to it. So we do this, greater or less than symbol here, and then we type in rigid body, just regular rigid body, which means it's a 3D rigid body physics component implicitly, and we got to close that with a the greater than symbol, and then open close parentheses. Wow. So here's the thing. We have right now a button that simply has a method defined where if this method would just get triggered, this code will execute. But how do we want this code, when do we want this method to get executed? Well, when we go up to this object and we look at it and we press the E button, that's what we want. So now we need to basically edit our player controller script because to just call this right away doesn't make sense. We want this boulder to drop as a result of pressing the button. So how do we handle button presses in Unity? This is where it gets kind of complicated. So just as a warning, I'll go slow, but let's look at our first-person player controller here. This top-level object, FPS controller. It's already got a first-person person controller script on it. I don't want to modify this existing script. I want to pile another script on this game object that is only concerned with the player's interactions with objects. So I'm going to create a custom script here in our scripts folder. Do create C# script, and I'm going to call it player interactions. Cool. Now I'm going to open this guy and open our code editor. So we got public class player interactions. Now you've been seeing this void start. Every time you create a class in Unity, you always see this void start and void update. And then you see these comments that describe what they do. Basically, all game objects have a void start method, which is called once at the beginning of the level when you load the scene, this level. It's got this structure called scenes, which is basically the levels or just, assets, like collections of assets that get loaded into memory, basically. So start gets called once at the beginning. So you use it for initialization usually. Like if you need to grab references to things, or assert that some things are a certain way, you do it in the start. Update is called once per frame. So update is where you want to constantly pull things like, hey, did somebody press the E key this frame? So most of our work is going to be concerned with being in this update method, really. So basically, what we're going to use to handle a button press here is we're going to use something called a raycast. Think of a raycast as a way of representing an invisible laser beam from a start location pointing in a certain direction. And raycasting is how you know where the player is looking. And it allows you to basically ask the question, is my player controller looking at this button right now? And then if so, we're going to then want to ask the question, hey, have they pressed the E key? Because if they press the E key, then we're going to want to call the do stuff method on the button, right? So that's what we're going to code up here. So we're going to use raycast code. Now, let's see. I am going to Unity raycast. I'm going to Google how to do raycast because I have not done this in forever. So here we got the cool. We've got the documentation for how to do a raycast. Is this in C#? Yeah, it's set to C# scripting language. Alright, cool. Now, we want an example of a raycast from the center of the screen outward. So we're going to do Unity raycast from center of camera. Here we go. Nice. Alright. So here's an example of a raycast from the center of the player camera. So I'm going to copy this code right here. Blah. And I'm just going to plop this right over here. Because this is boilerplate code. This is always going to this is going to look the same from basically any implementation of a raycast. It's always going to kind of look like this. So I don't have to do anything special. So here in that first-person controller prefab that we've been using, the camera component is on the object kind of beneath it. So let's grab our player interaction script and drag it to the inspector panel on this first-person character game object, which belongs to this first-person controller. It's a child object of it. That way we don't need to like descend through the children objects of the FPS controller to be able to grab our reference to this camera. We can just say grab it at this level because the script is at the same level as the camera component, if that makes sense. So here's what we'll do. We're gonna declare make it private camera, main cam, or still call it cam, lowercase. And then in the start method, we initialize it, we grab the camera component, now we always have a reference to the camera from this script, right? Now, here's what this code, this boilerplate code is doing. We're going to, from the middle of the screen, whatever direction the player is aiming, or the player's camera, which is basically just the player's head as far as you're concerned, we're going to throw this invisible laser beam, basically. And this laser beam is going to, let's see, what is viewport pointering? Yeah. That's right. Okay, so this basically says we're going to create a vector that goes from the direction that we are aiming our camera currently. And it's going to go a certain distance before we no longer care about how far the laser beam basically went. And then we initialize this raycast hit object, and basically we have this code that checks and says, hey, if our raycast that we designated here happens to hit something that has a collider on it. So in order for it to hit a game object, that game object must have a collider of some type on it for physics raycast to be to return true or false. So you'll see that there's raycast method. It takes an array and it outputs this hit info in the event that this is true. So this is basically saying if our raycast hits something, we have information about what it hit, and that information is stored in this variable called hit. So here's what we can do now. I'm going to remove what happens with this if statement. I'm going to put my own custom code. Now, here's what we can do. We can say, alright, if our raycast hits a object with a collider, and if input dot get button down and E, I guess, is what I want to. That's another thing I might want to check the Unity documentation on is how to detect that the E key has been pressed, because I'm not sure. So I'm going to search Unity E button press. And here we go. If input.get key down, here, I'll copy that code. Here's what I want. Key code. We're going to make this say down instead. We have multiple ifs, so let's get rid of that. Here we go. Get rid of that as well. Cool. So now it's like, all right, we are currently looking at an object with a collider. Now let's ask the question, did the player on this frame just hit the E key on their keyboard? And so if they did, what do we want to happen? Now, here's what we can do. We can say, this is interesting. Actionable. So remember how we have this hit variable that represents the object that we hit or some data about it? Now we can do if, and then open parentheses, hit dot collider dot game object dot get component I actionable object is equal to null, is not equal to null. So if this is if this object contains a script that is a iActionable object, so if it's not null when we try to get it, that means it is an actionable object. Then we can do, here, let's grab this in a separate variable. So if our object is equal to, we'll call it act object. So we're just going to do like a litmus test here and see if this actually is a actionable object that we have pressed the E key on. Let's remove this. So we're storing the result of trying to get a component of type iActionable object on this game object whose collider that we have hit, basically. So this variable act object could potentially be null. And if it's null, that means it's not an iActionable object. So we can now do if act object is not equal to null, then we can do act object dot do action, and that's finally what closes the loop right there. So we're like, are we looking at something with a collider? Yes. Is that, have we also hit the E key this frame? Yes. All right. Is this thing that we have been looking at and press the E key against a object of type iActionable object? Yes. If so, we're going to say we're going to do the action on whatever this iActionable object happens to have implemented for do action, and that's all we need. So now, here's the deal. This this should work, really. So what I'm going to do is, let's get back into the scene view, and I'm going to select this little button object right here, and I'm going to drag this button script onto the inspector panel. Because the script class, it says there's compiler errors with my button class, so let's see what the problem is. I'm going to try rebuilding it. Compiler will tell me what's wrong, if there is anything wrong at all. Yeah, it's weird. What doesn't it like? That's weird. I'm going to try again. Fuck it. Because the script class cannot be found. Oh, the file name and the class name match. That's the problem. Because remember, we renamed, in the class definition, we renamed it Boulder Button. That's stupid. Easy mistake to make. So let's actually name the class file Boulder Button. So this is a very specific case button. I'll teach you how to make it generic later. Now that we got the script named the same as the actual class definition, now I should be able to drag Boulder Button onto this cylinder that is the button that we want to actually look at. Cool. Now here it goes. Now that we have that set up, let's press play and check this out. We can go up this button, and I'm looking to the left of the button right now. I'm pressing E, and the boulder's not falling because I don't have the button right in the center of my view. But as soon as I do, I press E. Look what happened. I triggered it. Now, that is friggin' awesome. Yeah, so that worked. And I think that's where I want to stop the tutorial. So that was surprising that that worked the first time, but it did. So I'm happy with that, and if you need help setting this up and connecting the dots, you can feel free to share your code with me in some way, and I'd be happy to take a look at it. But that functions. Now here is an interesting thing. Check this out. This button, I can, with the way that this is written, I can be pretty far away from it right now. See, I just triggered the button from pretty far away. So I don't have enough checks. If I want to make sure that I'm close enough to the button to be able to press it, I need to add that logic in to the player interactions. So here is something that we can genericize. On iActionableObject, I also want to declare that all actionable objects should be able to report to me a number that represents the maximum distance that they can be from the object that we can act on by pressing the E button. So we're going to type int get max distance get max actionable distance. Here's something cool. This is generic. So now that we've declared that all actionable objects must implement this, we must implement this get actionable distance method on this Boulder button, because it's going to be unhappy otherwise. So public int get max actionable distance. It's going to take in no parameters, open, close. And for a Boulder button, let's see. I don't know. What would be a reasonable distance? Well, it's a good question. You can see there's this kind of light gray grid lines here, and this represents 1 unit each. So I would say 1 unit exactly for this button would be reasonable. If you're further than about, let's say 1.5 units, just to give it, some breathing room. So make it generous. So this method is only going to just return 1.0 f. And that f just says, rather than having me be specific about this literal value I'm putting in and the type that it fits into, we're putting an f so that this is going to be a float. And we're actually going to want to change this to be a public float. And also on the interface, we want to change this to a float, because we're going to want to be able to declare maximum distances that are between whole numbers, right? So that was an oversight on my part. So now this Boulder button always can report its max actionable distance. Well, now in the player interaction script, we need to use that data to, case that out so that the distance between your current player and the button is close enough for you to actually be able to do the thing. So now we have this check if this thing is actually a actionable object. So now basically the code that executes from here to here will only execute if this happens to be an actionable object. So once we're sure that this is an actionable object, we can have one more nested if statement that says if act object, or let's say if vector3.distance, and we pass in this dot transform dot position, and then comma, and then the position of that button, which is, well, act object is just a reference to the actionable object script, so we actually want the let's see. We'll want, it's a component, so we can do act object dot. We can't get back to the game object. So dot bait dot. I will just go back to the hit dot collider dot game object. We're going to pass in. If vector3 distance, so this method, this distance method, will return a, I believe, a float. It does return a float. So if the distance between these two things that I've passed in is less than the act object dot get max actionable distance, then we do the action on the actionable object. So it's very generic code, but this means that we can use actionable object in a very generic way and reuse this code basically, which is nice. So this is all the code that we're concerned with as far as our player's interaction with the actionable object, and then it's just up to us to script unique behaviors per object that inherits this behavior of actionable object. So now with that, we have ensured that we have to be at least 1.5 grid units close to the button for it to trigger. Let's see what problem this code has. Oh, I think I messed up. Hey, collider.gameObject. Oh yeah, duh. I didn't even pass the position. I just passed the reference to the game object. So I want gameObject.transform.position. Now it will have no problem with it, because this distance method expects 2 parameters of vector3 type. I was passing in game objects. So it was basically saying a vector3 is not a game object. Why are you passing me a game object? So now this will clear up. Now when we play this, I can look at this button, place it right in the center of my viewport from here, spam the E button. Does not trigger the boulder fall. Let's get a little bit closer. Still not close enough. Still not close enough. I'm really spamming the E button. It's in the center. It's not triggering. Let's get a little bit closer. Still not close enough, apparently. Let's get just a little bit closer. Ooh. And there. I was finally close enough, and I got it to trigger. So cool. Yeah. And also, because this is this ramp has a collider, I can jump up it and climb around on it and stuff. So yeah, that's our trigger button setup. And the next video I make will basically be how to make it more generic, so that it's not specifically a boulder button, but a button that can just do something. And that separation will be very nice in terms of clean code. So yeah, until next time.